Today we're going to be talking about solving linear equations. An equation always has an equal sign that splits up the left-hand side, which is this, from the right-hand side, which is this. We know an equation when we see one because there is always a solution to the equation. And in terms of variables, in this case, it would be finding out what value of x makes this equation true. So from intuition, you can probably just guess that if you have a value of x as 4, you can plug in 4 for x, and the equation would be 4 plus 2 equals 6, which makes perfect sense because that's 6 equals 6. But a more concrete and reliable method is to try to solve linear equations, which is what I'm going to teach you today. So one thing to note about linear equations is whatever you do to one side, you can always do to the other. We can subtract 2 from this side, and that means we'll have to subtract 2 from the other side. Whatever you do on the left-hand side, you have to do on the right, and vice versa. So you can subtract 2 from both sides, and the equation is still equal. So you take the equation x plus 2 equals 6, and you subtract 2 from both sides so that you isolate the x on the left-hand side. And so what happens when you subtract 2 is your equation will then be x is equal to 4. And that's just your answer right there. Let's try the next one. This time it's negative 8y equals negative 24. This time, instead of subtracting, what we can do is we can divide instead. So if we divide both sides by negative 8, negative 8y divided by negative 8, that's just y. So you have y on the left-hand side, and negative 24 divided by negative 8, that's 3, because negative divided by negative is a positive. So your answer will be positive 3. And so this is your answer for the second problem. Now let's try this last one here. First, let's simplify the right-hand side because there's a parentheses. So we're going to have this is equal to 5z minus 15 is equal to 3 plus 7 is 10. So this is our equation here. And we can add 15 to both sides. So plus 15 and plus 15. And we will get 5z is equal to 25. And so now we can divide by 5 on both sides. And we'll get z isolated. Z is equal to 5. And that is our answer. Now with all of these, you can proof check them by plugging in the value of the variable you end up with back into the equation. And we see if we plug in 4 for x, we get 4 plus 2 equals 6. Okay, that proves it's correct. How about this next one? Let's get rid of the y here, and instead it would be negative 8 times 3. Negative 8 times 3 is negative 24. Okay, second one's right as well. And then the last one, we'll plug in 5 for z. So it'll be 5 times 5, which is 25. And so we know 25 minus 15, that's equal to 10. And the right-hand side is 3 plus 7, which is also equal to 10. So we know that this is also right. All right, these equations are a little more complicated as we have 2 variables now. For instance, in the first one, we have p and q, but we are given the value of one of the variables. So let's plug in q here because we're given q equals 2. And so we'll have p plus 2 is equal to 32. And we can subtract 2 from both sides. And so we'll have p is equal to 30. And so this is the answer for the first one. Let's try the next equation. We have the value of y equals 2. So let's plug in y first. So in the parentheses, we have 3y. And y is 2, so that would be 3 times 2, which is 6. So our equation will be 2x times 6 is equal to 60. 2x times 6 is 12x equals 60. And so now we can divide both sides by 12. And on the left-hand side, we have x isolated. Perfect. X is equal to 5. So that's our answer. Lastly, let's solve this third one here. So x equals 4. So let's plug in 4 for x. So we'll have 20 plus 4 And we know that is going to be 24 equals 6y. And so we can divide both sides by 6 in order to isolate the y variable here. 24 divided by 6 is 4. And on the right-hand side, we have y. 4 equals y, so that means y is equal to 4.